Bernd Michael Rode. Bernd Michael Rode, born July 14, 1946 in Innsbruck, Austria, is an Austrian professor of chemistry at the University of Innsbruck and founder of the Austrian-South-East-Asian Academic University Network ASEA-UNINET. Prof. Rode has been retired in 2011, but he is still actively involved in teaching and research as well as in the thesis supervision. Biography. In 1964, Bernd Michael Rode graduated from high school Akademisches Gymnasium Innsbruck and commenced studies in chemistry at the University of Innsbruck. In 1973, he received his PhD degree in chemistry with sub auspiciis praecedentes from the University of Innsbruck. In 1973, Prof. Rode started his career as an assistant professor at the Institute of Inorganic and Analytical Chemistry of the University of Innsbruck. After research stays in Germany, University of Stuttgart and University of Karlsruhe, he became an associate professor in Innsbruck in the year 1976. After spending a one-year research stay at the University of Tokyo, Prof. Rode started his professorship at the Institute of Inorganic and Theoretical Chemistry at the University of Innsbruck. From 2006 to 2011, he was head of the Department of Theoretical Chemistry and head of the Institute for General Inorganic and Theoretical Chemistry. One of Prof. Rode's largest achievements was the foundation of the university network ASEA-UNINET, Austrian-South-East-Asian University Partnership Network, in 1994. The foundations for this network were laid by informal contacts between the University of Innsbruck and Thai universities that date back to the 1970s. In the 1980s, partnerships between the University of Innsbruck, the University of Vienna, the University of Agricultural Sciences Vienna, the Chulalongkorn University, the Mahidol University, the Kasetsart University, and the Chiang Mai University were concluded, with the target to unify these bilateral partnership agreements into one multilateral network. Prof. Rode invited interested universities from Austria, Indonesia, Thailand, and Vietnam to participate in the first ASEA-UNINET plenary meeting in Ho Chi Minh City. In 1994, the network comprised 25 universities from Austria, Thailand, Indonesia, and Vietnam. As of June 2014, more than 70 universities from 16 European and Southeast Asian countries participate in the network. In addition to his scientific and networking activities, Prof. Rode served during the periods 1998-2001 and 2005-2008 as Vice President in the United Nations Commission on Science and Technology for Development UNCST, representing the WIOG states EU, USA, Canada, and Australia. In 2004, he became the first Austrian to serve as president in the United Nations Commission on Science and Technology for Development. Awards and decorations. For his commitment in Asian countries, Prof. Rode has received many awards, amongst others the honorary doctorate degree in Sciences of the Chulalongkorn University, Bangkok 1995, the honorary doctorate degree in Sciences of the King Mongkut's Institute of Technology, Lat Krabang, Bangkok 1998, and the honorary doctorate degree in Sciences of the Gajah Mada University. In 2007, the King of Thailand awarded Prof. Rode with the Knight Grand Cross First Class, the most noble order of the Crown of Thailand. In 2008, the Comenius University Bratislava awarded him an honorary doctorate degree for his pioneer work in quantum chemistry studies of molecule and supermolecule systems of ion solvation and molecular modeling of biomolecules and medicaments. In 2014, he was appointed honorary president of ASEA-UNINET. Overview: most important awards and decorations. 1985 Goldines Ehrenzeichen, Republic of Austria. 1994 Austrian Decoration for Science and Art, Republic of Austria. 1997 Honorary Member, Slovak Chemical Society. 2003 Cross of Merits, State of Tyrol. 2004 Cross of Merits, Austria. 2007 Cross of Honors in Science and Arts First Class, Republic of Austria. 2008 Jan Weber Medal of the Slovak Pharmaceutical Society. 2010 Sitara Ekade, I Azam Civil Decoration of Pakistan. 2011 Knight Grand Cross First Class of the Most Exalted Order of the White Elephant with / according to the Theoretical Chemistry Genealogy Project, Bernd Michael Rode is the most successful doctoral thesis supervisor of German-speaking countries in the field of theoretical chemistry. Between 1976 and 2011 Prof. Rode has led not less than 70 students to their PhD degree. Due to his close contacts to Southeast Asia, many of them come from Asian countries. Research activities. Bernd M. Rode's scientific achievements are reflected in 7 monographies/books, more than 440 publications in international research journals, and 30 book contributions. According to ISI Thomson's Web of Science citation report, these contributions received more than 8,300 citations as of May 2014 with a Hirsch index of 41. Prof. Rode's research focus lies in theoretical and computational, well as bioinorganic chemistry. In detail, his publications emphasize on the following aspects: quantum chemical calculations of molecular and supramolecular systems, ab initio Monte Carlo and MD simulations of liquids/solutions, electrolyte solution structure, ultrafast dynamics of solutes, molecular modeling of biomolecules and drugs, QSAR/QSPR, chemical evolution of peptides/proteins and origin of life, theoretical chemistry. Although Prof. Rode's initial research activities were in field of inorganic chemistry, he soon extended his expertise into the rapidly developing field of theoretical and computational chemistry. Whereas in the beginning most studies focused on quantum chemical computations of a broad range of chemical systems, later application focused on the application of chemical simulation techniques such as Monte Carlo and molecular dynamics, mostly in the context of solution chemistry. A particular notable contribution of Prof. Rode's research is the development and application of hybrid quantum mechanical/molecular mechanical simulation techniques, focusing on a broad range of problems in solution chemistry. In 2004, an improved technique known as quantum mechanical charge field molecular dynamics explicitly aimed at the treatment of solvated systems has been developed in Prof. Rode's research group. During the last years, the application of this technique enabled accurate simulations of ionic compounds and organic species, as well as coordination complexes in aqueous solution. His most recent research is focused on the lanthanoid ions in aqueous solution. Chemical evolution. Prof. Rode's second main field of research lies in the area of bioinorganic chemistry, in particular abiogenesis. At the end of the 1980s, Prof. Rode and his co-workers discovered the salt-induced peptide formation reaction as a simple route to synthesis peptides from amino acid monomers under prebiotic conditions. Instead of enzymes, transition metals act as catalyst to induce peptide formation in highly concentrated aqueous NaCl solution, with copper Roman II showing the highest catalytic activity. Typically, evaporation cycle experiments have been carried out to mimic day/night cycles on shore and in lagoons, thereby generating supersaturated solutions. Since such solutions have a tendency to dilute themselves, the thermodynamic and kinetic unfavorable peptide formation reaction is promoted. The research conducted by Prof. Rode investigates the properties of the salt-induced peptide formation reaction under various conditions, highlighting also its possible connection to biohomochirality. Furthermore, Prof. Rode also carried out Miller-Urey experiments, taking new insights of the composition of the primordial atmosphere into account. It was shown that peptides may also form in a neutral atmosphere C(O2)/H2O subject to electric discharges. Malvisioner, together with his PhD student Hung Tung Tran Prof. Rode developed the practical and flexible visualization software Malvisioner capable of interactively analyzing dynamic simulation data. In 2003, Dr. Tran was awarded with a European Innovation Award for the development of this program. Publications: Tengrar, A. Liedl, K.R. Rode, Bernd M. 1997, Salvation of Catwo Plus in Water studied by Born Oppenheimer ab initio QM/MM Dynamics, J. Fies. Chem. 1997, 100-135, p. 6299, 6309, doi 1021/JP 970963. Rode, Bernd M., Schwenk, Christian F., Tengrar, and in 2004, Structure and Dynamics of Hydrated Ions New Insights Through Quantum Mechanical Simulation, J. Mall. Lick. 2004, 110-3 pp. 105-122. doi 1016/J. Malik. 2003. 9. 16. Hofer, Thomas, Pribyl, Andreas, Randolph, Bernhard, Rode, Bernd M. 2005, Structure and Dynamics of Solvated SN Roman II in Aqueous Solution and ab initio QM/MMMD Approach, J. M. Chem. Soc. 2005, 12741, p. 14231, 14238. doi 1021/J52700. Rode, Bernd M., Schwenk, Christian, Hofer, Thomas, Randolph, Bernhard 2005 Coordination and Ligand Exchange Dynamics of Solvated Metal Ions Coord. Chem. Reverend. 2005, 24924 pp. 2993-3006. doi 1016/J. CCR. 2005. 3. 32. Rode, Bernd M., Hofer, Thomas 2006. How to Access Structure and Dynamics of Solutions, the Capabilities of Computational Methods, Purapol. Chem. 2006, 78-3 pp. 525-539. doi 1351/Pact 100 billion, 678,030,525. Rode, Bernd M., Hofer, Thomas, Randolph, Bernhard, Schwenk, Christian, Zenides, Demetrios, Vikairawanquin, Viwatwo 1006. Ab initio Quantum Mechanical Charge Field QMCF Molecular Dynamics a QM/MMMD Procedure for Accurate Simulations of Ions and Complexes, Theor. Chem. Ac. 2006, 115-03 pp. 7785. doi 1007/S214-549-1. Hofer, Thomas S., Randolph, Bernhard R., Rode, Bernd M. 2008, Molecular Dynamics Simulation Methods Including Quantum Effects, Insolation Effects on Molecules and Biomolecules, Canuto, Silvio eds. ISBN 978 14028,269-6 Springer, Heidelberg 2008 pp. 247-278. Rode, Bernd M., Hofer, Thomas S., Pribyl, Andreas B., Randolph, Bernhard R. 2010, Simulations of Liquids and Solutions Based on Quantum Mechanical Forces in Theoretical and Computational Inorganic Chemistry, Van Eldik, Rudy, Harvey, Jeremy eds. ISBN 978-012-380,874-5, Elsevier, Amsterdam 2010 pp. 143-175. Hofer, Thomas S., Pribyl, Andreas B., Randolph, Bernhard R., Rode, Bernd M., Ab initio quantum mechanical charge field molecular dynamics a non-parametrized first principle approach to liquids and solutions in Advances in Quantum Chemistry. ISBN 978-012-380,898-1, Elsevier, Amsterdam 2010, 213-246. Jackschitz, Thomas, Fitz, Daniel, Rode, Bernd Michael 2012, The Origin of First Peptides on Earth, From Amino Acids to Homochiral Biomolecules, in Genesis in the Beginning, Joseph Seckbach ed. ISBN 978-94-729-47, Springer, Dordrecht 2012 pp. 469-489. Lutz, Oliver M. D., Messner, Christoph B., Hofer, Thomas S., Latzel, Matthews, Huck, Christian W., Bonn, Gunther K., Rode, Bernd M., Combined ab initio computational and infrared spectroscopic study of the cis and trans bisglycinaticoper Roman II complexes in aqueous environment, J. Fies. Chem. Let. 2013, 4 p. 1502-1506. doi 1021/JZ 400,288. Schwendinger, M.G., Rode, Bend M., 1990. Copper-catalyzed amino acid condensation in water, a simple possible way of prebiotic peptide formation, origins life of all. Biosphere 1990, 25 pp. 401-410. doi 1007/bphone1,808,134. Schwendinger, M.G., Rode, Bend M. 1998, Possible Role of Copper and Sodium Chloride in Prebiotic Evolution of Peptides, Anal. Sci. 1989, Pfeiffer pp. 411-414. doi 2116/Analsky. 5. 411. Plankensteiner, Christoph, Riener, Hans, Schrantz, Benjamin, Rode, Bernd M. 2004, Prebiotic formation of amino acids in a neutral atmosphere by electric discharge, Anjou. Chem. Int. ed. 2004, 43 pp. 1886-1888. 1. Fitz, Daniel, Riener, Hans, Rode, Bernd M. 2007, Chemical Evolution Toward the Origin of Life, Purapol. Chem. 2007, 7912 pp. 2101-2117. doi 1351/pact 100,779,122,101. Fitz, Daniel, Jackschitz, Thomas, Rode, Bernd M. 2011, Salt-Induced Peptide Formation in Chemical Evolution. ISBN 978-3642-21624-4, Springer, Heidelberg, Berlin 2011 pp. 109-127. Jackschitz, Thomas A., Rode, Bernd M. 2012, Chemical Evolution from Simple Inorganic Compounds to Chiral Peptides, Chem. Soc. Reverend. 2012 4116 pp. 5484 5489. doi 10.1039/C2 CS35073D. Rode, Bernd M., Plankensteiner, Christoph 2013, Prebiotic Peptides, in Handbook of Biologically Active Peptides, 2nd edition, Abba J. Caston eds. ISBN 978-12-3850959, Elsevier, Amsterdam 2013 pp. 1899-1903.